Lesson 9.2, Solving Quadratic Equations by Graphing. Our essential question is, what do the solutions of a quadratic equation represent? Our vocab word says, how many solutions does a quadratic equation have? So the key concept that we have copied here shows you that there are three different situations that can occur when you graph a quadratic equation. The first situation says that there are two unique real solutions. The second one says one unique real solution, and the third one says no real solutions. So you may be wondering how you can find the solutions from a graph. In red, you can see the answer. The solutions are the x-intercepts of the graph. If the graph doesn't cross the x-axis, then it has no real number solutions. So with two solutions, on this first graph, you can see that there are two spots where the parabola goes through the x-axis. On the second one with one solution, the vertex sits on the x-axis, so there's only one solution. And then in the third one, there are no real solutions because that quadratic, that parabola, doesn't cross through the x-axis at all. So solving a quadratic. In Chapter 8, we solved quadratics. We did. But we solved them using a different method. We factored them and then used the zero product property. So throughout Chapter 9, our goal is to provide you with a lot of different ways to solve a quadratic. You already know how to solve by factoring. In this lesson, we're solving by graphing. We will also teach you to solve by completing the square and to solve by using the quadratic formula. Our goal is to provide you with a lot of different methods for solving quadratic equations. Okay, so solve by graphing. This first problem, you could certainly use a graphing calculator. If you're using a graphing calculator, you would go to the y equals screen and you would enter in x squared minus 2x minus 8. And then you would look for the x-intercepts on your graph. You may need to use the trace feature, you may need to zoom in, or you may be able to just find the x-intercepts right away. So to graph this, we learned in a previous section how to graph. So I am going to find the axis of symmetry. X equals the opposite of b over 2a. A is 1, b is -2, and c is -8. So the opposite of -2 is +2, and 2 times 1 is also 2. 2 divided by 2, my axis of symmetry is x equals 1. Next, I need to find my vertex. So I can plug in 1 for x, 1 squared, minus 2 times 1, minus 8. 1 squared is 1, minus 2 minus 8, so -9. 1 -9, it's right here. And then c is -8, so -8 would be right here, and if I reflect it to the other side, I could draw my graph. The problem is I need to figure out the x-intercepts though, so I don't see them right now. So what I'm going to do is I'm going to say x equals 1, 2, 3. I'm going to plug in 3. So if I plug in 3 for x, I need to find a couple more points. So 3 squared is 9, minus 2 times 3 is 6, minus 8. 9 minus 6 is 3, minus 8 is -5. I need to find a couple more points because I need to get closer to this x-axis. Now, how about if I plug in 4? 4 squared is 16, minus 2 times 4 is 8, minus 8 is 0. So I just found one. 4, 0. And then if I balance it on the other side of my symmetry line, oops, I balanced that other one a little bit off.
So if the other one was only 2 away from my symmetry line, this is 3 away, so it would be right here. So now I can draw my quadratic, and I've successfully solved by graphing because this x-intercept right here is 4, and this one over here is -2. So there are 2 real number solutions, and they are 4 and -2. My next one, I'm going to solve by graphing again. A equals 1, B equals -6, and C, I actually have to move over to the other side because standard form, you have to have one side equal to 0. So if I move this over, it would be x squared minus 6x plus 9 equals 0. So C is positive 9. Okay, axis of symmetry. X equals the opposite of B over 2A. So -6 over 2 times 1, which is 2. The axis of symmetry, x equals -3. So here's my axis of symmetry. Okay, then my vertex. Take that -3 and plug it in. -3 squared minus 6 times -3 plus 9. So 9 plus 18 plus 9. So my vertex is way too high to fit on this graph. So -3, 36. I think there's a mistake here somewhere. So, where could our mistake be? Right here. B is -6. So this should be a positive. Positive on my 3, because clearly that was not going to give me a vertex that would be easy to graph. So, plug in 3, 3 squared minus 6 times 3 plus 9, 9 minus 18 plus 9 is 0. So 3, 0. So I've got to move my symmetry line because I had my symmetry line in the wrong spot. It was supposed to be at +3. And we've just found the vertex. The vertex is at 3, 0. So it's sitting right on the x-axis. Now, my y-intercept is the value for C, which is 9. So my y-intercept is up here at 9. I balance it on the other side of my symmetry line. And this quadratic has got one solution right here. X equals 3. It only hits the x-axis once. All right, example number 3. See if we can do this one with no mistakes. That would be nice. All right. A is 1, B is 2, and C is 3. Axis of symmetry, x equals the opposite of B over 2 times A, -2 divided by 2, so -1. Then, plug it in to find the vertex. -1 squared plus 2 times -1 plus 3. -1 squared is 1 minus 2 plus 3. So this would equal 2. So -1, 2 is the vertex right here. And then the y-intercept is C. So the y-intercept is 3. On the y-axis, 3 would be right here. Balance it on the other side of the symmetry line, and we've got no solutions. This quadratic does not go through the x-axis at all. So we have seen one of each type of problem. If it crosses through the x-axis twice, you need to name both of those.
X-intercepts, they are both solutions to the quadratic. If the vertex is on the x-axis, you've got only one solution to name. And then if the quadratic is up above, or if it was entirely down below, because it could be down below like this, there would be no solutions. You should be able to write a summary now. And here are your homework problems. If you're using a graphing calculator, I want to see just a little sketch. So for example, it doesn't have to be exact, but I want to see a little sketch that shows where your parabola is, and then on an example like this, this would be no solution. So you can do empty set or no solution. If there are solutions, I want you to name them. So you don't have to be specific on your graph with your marks, but you draw your sketch. Let's say that your quadratic looks like this. You draw your sketch, and you've got to also say what your solutions are. So on this one, I would have 1 and -1 as my solutions. So again, you don't have to be exact with your tick marks and everything, but I want a sketch that shows me that you graphed it on the calculator, and I can see that you're understanding how many solutions you should be finding to go with each graph.